All right, let's take a look at this. Again, I'm doing this problem because I want to see a pattern, okay? So let's do this problem like we know how. We're going to divide it as a fraction, so we're going to change this to an improper fraction. 2 times 10 is 20, plus 1 is 21 over 2, divided by 5. I'll put the 5 over 1. Remember what we have to do again? When we divide fractions, we're going to change the division to multiplication and use the reciprocal of this number. So it's 21 over 2 times 1/5. Nothing to reduce, so we're just going to have to multiply across, is 21 over 10. Now, just for sake of seeing patterns, I'm going to change this to a mixed number. 10 goes into 20 twice, remainder 1, 1/10. Now watch this. This is fine. That's a great example of dividing fractions, but I want you to see a pattern. So here's what I'm going to do. I'm going to change all of these to decimals. Now, here's the problem. We said before that decimals were fractions whose denominator is 100 or 10, some power of 10. That's not a power of 10. So I'm going to show you what I'm going to do. I'm going to build that fraction. I'm going to take 1/2, forget about the 10 for a second. I'm going to take 1/2 and build it because I can make it have a denominator of 10. And that's what I want to do. So multiply this by 5, multiply this by 5, and I get 5/10. So actually, this is 10 and 5/10 divided by 5. And we know that equals 2 and 1/10. You might be saying, well, you changed the question. That's not right. Yes, it is. Remember, these are equivalent, 1/2 and 5/10. So that's what you'd get. You just have to reduce at the end. No big deal. Okay, so I'm now going to change this to decimals. Watch what this says. This says 10 and 5/10. So 10 and 5/10 divided by 5 equals 2 and 1/10. 2 and 1/10. What we're doing is we're dividing a decimal by an integer, okay, by a non-decimal or an integer, okay? And do you see a pattern? What do you do here? This was just so easy. All we did was bring a decimal up and divide like there was no decimal at all. 5 goes into 10 twice, 5 goes into 5 once. So it's so easy to divide a decimal by an integer. All you do is bring the decimal up and divide as usual. Very, very, very simple. Be sign conscious, but if we have some negatives and positive numbers. So let's do some division. Here we go. Let's find the quotient. Remember, find the quotient means to divide. So let's divide here. Okay. I'm going to do long division. Dirty monkeys, come back. Dirty monkeys. Negative 93.6 or 93 and 6/10. Take care of the sign first. When you have different signs and you're dividing, the answer is negative. So here we go. I'm going to do this problem. In fact, you know what? I don't want you to look at the sign. I'm afraid the sign will be distracting. So let's do that here. Don't worry about the sign. We'll put the answer over there. 4 into 9. Remember, dirty monkeys, divide first. 4 into 9 goes twice. 2 times 4 is 8. Subtract, we get a 1. Bring down the 3. 4 into 13. 4 into 13 goes 3 times. 3 times 4 is 12. 13 minus 12 is 1. You may want to have brought out that decimal right away. I should have did that. I should have brought the decimal up right away. In fact, you should probably want to use even a different color. But it's okay. There it is now. Bring down the 6. Okay. 4 into 16 goes exactly 4 times. We get 16, remainder nothing. So we have negative 23.4. Awesome. Or 23 and 4/10. Be sign conscious there. And by the way, this is called a terminating decimal. What makes it a terminating decimal? It ends. 4 is the last number, nothing else. Notice that in your workbook, it says terminating decimals are decimals that end, and there's some examples of them. So this is negative 213.45 divided by negative 15. Divided by means this is the outside number. Bye-bye. That goes outside. Bye-bye. Okay, but remember, let's be sign conscious. The signs are the same, so the answer is going to be positive. Ready? All right, we're going to do this one nice and slow. Lots of numbers going on here. I'm going to bring the decimal straight up. Because you know how straight I always write. This should be good. Okay, 15 doesn't go into 2, but 15 goes into 21 once. We get 15. That's the multiplication step. Now we subtract. 21 minus 15 is 6. Bring this down. 15 and 63 goes 4 times. Now we multiply. 15 times 4 is 60. Now we subtract. We get 3. We bring down. 15 into 34 goes twice. 2 times 15 is 30. We subtract. We get 4. Bring down. 15 into 45 goes exactly 3 times. We get 45. No remainder. Our answer is positive 14.23. Awesome. I hope they're all that easy. Don't count on that, right? I don't need that positive sign if you don't want it. Ready for another one? This next one looks really interesting. Look at this next one. Looks really, really interesting. Okay. We're going to take this one really, really slow. This is a new type, kind of. Here we go. Something cool is going on. This is find the quotient of negative 5.98 and 115. I'll tell you why I did that. I want you to make sure you understand what's the number that's outside and what's the number that's inside. Okay, watch this. First of all, I know this is going to be a negative answer, so I'm going to rewrite it like this. Actually, that's the number that stays outside. I like doing it that way, so I know that stays outside, that stays inside. I'm going to thank my 9th grade teacher for that. She showed me that. I'll thank her right now. Thank you. Okay, anyway, here we go. 115 doesn't go into 5. If you'd like to put the 0, you can. You don't have to. We haven't been, but if you'd like to, you can. 115 does not go into 59. That 0 you have to put in. Absolutely have to. Because that is the tens place. Have to put that in. 115 into 598. Okay, so I'm thinking it goes about 5 times. Let's see. 5, 2, 5, 7, 5. Oh, good. All right, so 5 times. That's 575. Now we have to subtract. 8 minus 5 is 3. 9 minus 7 is 2. Okay, so that's 23. Now listen. We can't have a decimal with a remainder. I mean, talk about sloppy. We can't have that. So since you can't have a decimal with a remainder, we have to add a 0, bring that down. Beautiful. I'm thinking that's 2. In fact, I know that's 2. That's 2. 2 times 115 is 230. Exactly. So that's my answer, negative 0.052. Awesome. Awesome. You knew it had to be a really small number because you're putting a big number into a very small number. Okay? That is a terminating decimal because it ends. All right, let's take a look at repeating decimals. Okay, a repeating decimal is a decimal that stutters. Only kidding. Joke. That was a joke. It was a good joke. All right, here we go. Here's an example of a terminating decimal, 0.333. It ends. In fact, if I want to write that as a fraction, I can. 333, be careful, 333 thousandths. However, here's an example of a repeating decimal, 0.333 ... That 333 tells me that's the pattern that goes on forever and ever and ever. That's what the ... says. Okay, that ... is called an ellipsis. Okay, ... tells me it goes on without end. 0.333 tells me that's the pattern, 33333. Another way to write this is 0.3 with a bar over it. Okay, that tells me that's what repeats. Okay, notice there are other repeating decimals in your workbook. For instance, this one. I'm not going to write the whole one, but it's 8.10535353. ... Notice, here's 53, 53, 53. When I do this ... I really should see 3 cycles of the pattern. 1, 2, 3, 3 cycles of the pattern before I write the ... That tells me that's what's repeating. If I write it with the bar, it looks like this. 8.1053 bar. The bar is used instead of a rounding. That kind of says, hey, I'm going to give you the exact number. This is 53, 53, 53, 53, 53, 53, 53, 53, forever. Okay? So the bar is in place of rounding. All right. So let's take a look at all our sets of numbers then. We had the natural numbers, 1, 2, 3, 4, 5, 6, dot, dot, dot. Then we added a 0. We got the whole numbers, 0, and remember, whole, 0, whole, okay, thanks. 0, 1, 2, 3, dot, dot, dot. Then we got the integers, which added the negatives, -3, -2, -1, all of those, okay, but no fractions or decimals. Then we got the rational numbers, which were any number that can be expressed as a fraction, okay, and that included all the numbers I just said. And then apart from all of those sets is an irrational number. Irrational numbers is a set that stands alone. It is a real number, but it is not rational or natural or whole, but it is a real number. And the only type of irrational numbers we know are non-repeating, non-terminating decimals. And I said we know, but truly there is. The only type of irrational number there is are non-repeating, non-terminating decimals. Something like if I had 4.671293 dot, dot, dot. I don't end and I don't repeat because I have no idea what might repeat here. Nothing is repeating. Otherwise, we would have had a cycle of 3. So those are the different types of decimals. It is so important to understand the different types of decimals. Okay. In this next problem, it says we're going to round each to the nearest thousandths. If we're going to round to the nearest thousandths, here's the bad news. If we're going to round to the thousandths, that place, we're going to have to go to the next place. So we're going to have to go to the 10,000th place if we have to round it all. Okay. 267.01 divided by 13. Divided by 13, by 13 goes on the outside. Dirty monkeys. I'm seeing some dirty monkeys here going on. Taking my blue pen, getting a little board of black. Okay, 13 goes into 26 twice. That is 26. Subtract, we get 0. Bring down, 7. Okay, you know what? I'm going to bring this right up so I don't screw this problem up. Okay, 13 does not go into 7. Yes, we have to put a placeholder there. Bring down. 13 goes into 70, how many times? 13 times, let's try 5. Okay, I'm going with 5. That's 65. Subtract, we get 5. Oh, that would be a 1, not a 0. Good thing I'm here. Whoa. Okay, 13 into 51, let's try 4. 13 times 4 is... I knew that wouldn't work. What am I thinking? Okay, so it's 13 times 3. 13 times 3 is 39. Subtract. Borrow. Here we go. Told you seatbelts. Add a 0. Remember, can't have a remainder with a decimal. Add a 0. Oh, this is just way too much fun. Try 9. 13 times 9. 27, 2. 117, not bad. 117 remainder 3. I could run out of board space. Not really, I only need one more number. Okay? That's 30. 13 goes into 30 twice. I don't really care what goes on after that. So if I'm rounding to the nearest thousandths, tenths, hundredths, thousandths, I just need that number to look at. So I have 20.5392. Tenths, hundredths, thousandths. I look here. It's not a 5 or higher, so I leave this alone. So this is approximately 20.539. Okay, let's take a look at this one. We're going to divide, and this is dividing by 9, so by 9. So a 9 goes on the outside. 10.22. Dirty monkey, so we're going to divide. So 9 goes into 10 once. Okay. Bring up that little decimal before I forget. 1 times 9 is 9. We're going to subtract. We get 1. We bring down the 2. 9 goes into 12. Oh, good. Numbers I can divide easily. Awesome. Okay. 9 goes into 12 once. 1 times 9 is 9. We're going to subtract. We get 3. Bring down the 2. 9 goes into 32 3 times. That's 27. 32 minus 27 is 5. Oh, we're going to have to add a 0. Of course we are. 9 goes into 50. 5 times, that's 45. Notice what's going to happen. Notice what's going to happen. We're going to get that 50 again. Notice what's going to happen. So we're going to get another 5. Notice what's going to happen. We're going to get that 50 again. 50 again. So this answer is, let's take a look at it, 1.1355. And we're going to keep getting the 5. Now, if I wanted to write this exact, I would write 1. I could write it like that, or I could write it like this. Line over the 5. But that's not what it's asking me to do. It's asking me to round to the nearest thousandths. So I'm going to go 1.1355. This is the thousandths. I look at this, and I have to round that up. So it's 1.136. So 1 and 136 thousandths. Very cool problem. I like that. That was a repeating decimal. Why is it repeating? Because the 5 kept repeating. Okay? Never ends, and it's got something that goes on, that repeats. Something that keeps coming up. Okay, so it's 1.136, approximately. Remember, it's approximately because you've rounded it. Okay, ready for this one? 11. 11 is my friend. 11 where we get these really cool patterns. Let's take a look at 11. We're dividing by 11, by. Okay. 116.3. Ready? Here we go. 11 goes in 11 once. I'm going to bring up this decimal before I forget. Okay. And we get 11. We get 0 down here. Bring down the 6. 11 does not go into 6. We do need that 0. Okay. And now we bring down the 3. 11 into 63 is 5. That makes 55. I subtract. I get 8. 63 minus 55 is 8. I have to add a 0. Of course I do. I get 7. Could never end. Okay, 11 times 7 is 77. Subtract. I get a 3. Bring down the 0. 11 into 30 is 2. I get 22. Subtract. I get 8. 8. Oh, I got that before. I got that before. Okay, bring it. I get 7. And, okay, I'm done here, but I want to talk about this in a minute. I'm rounding to the nearest thousandths, so this is 10.5727. I'm rounding here. This is a 5 or higher. I need to move it up. So it's approximately 10.573. That's the approximate answer rounding. But notice what was going to happen. I was going to get 7272 again. So the exact answer, if you care, and I know you care, if you care, the exact answer, let me write this here. The exact answer would be 10.572. What's going to keep going? 72 is going to keep going. So the 72 would have a bar over it. Okay, just the 72 would have a bar over it. Exact, approximate, rounding to the nearest thousandths. Pretty cool. All right. So we're done dividing by an integer. Notice that the only thing we've ever divided here was by an integer. Okay, next time we're going to divide a decimal by another decimal. Oh, can't wait.